Tapping into virtual networks, Wireshark and GNS3, it's like a match made in heaven. Let's begin. I'd like you to imagine that you and I are managers of an IT department in a fairly large company, and we have an intern in the IT department who walks up to us and says, you know what, I'm learning in school about all these new things like VLSM and gateway load balancing protocol and some other things. Can I go ahead and try those out on your network? Now, what is the answer we're going to give this person regarding testing things out on our production network? Yeah, I'm totally with you. We are going to say, no way, you're not touching our production network. However, perhaps we can set up a test environment for them. So let's say we look around and we decide that we don't have a lot of extra hardware that we can allocate to this intern for their personal practice. What else could we do? One terrific answer is to emulate the network with a tool like GNS3. It's open source, it's free, and it's absolutely terrific. If you're interested in more detail about GNS3 specifically, have no fear. There's an entire GNS3 series waiting for you as part of your IT subscription at CBT Nuggets. What we get to do right now is take a look at what does the normal packet flow look like on a network for a specific type of application like HTTP or DNS. We'll then take a look at how that same type of network could be emulated with GNS3. Now in this video, my goal is not to teach you GNS3. Why? Because there's already a complete series on GNS3 available to you. However, what I would love to do is walk you through how we can integrate and take advantage of Wireshark listening in and doing packet analysis at various points in that emulated network that can give us a really good insight as to what's really going on with an application at any point in the network. Regarding this first objective, what should a packet flow look like, a normal packet flow? Let's start off with the scenario. Let's say we have a happy user, and he's happy because he's about to go out to the internet. He opens up a browser, types in www.google.com, presses enter, and let's say Google is out here on the internet, which it is. There's the Google server. I'll document that. There's the Google server. Now, what would happen? So if he types in google.com, he or she, how does it work? Now, if you're looking at this saying, well, it would go out to google.com and just open up the web page. Yes, that's what the user experiences. I'm totally with you there. But behind the scenes, what has to happen? And then you might be saying, okay, Keith, the first thing that has to happen is google.com needs to be resolved, very likely through DNS, to an IP address. Great, absolutely. So we need to send out a DNS request. If our DNS server is out at 8.8.8.8, our DNS request has to go out here. Now, if our DNS server is at 8.8.8.8 and our PC is on this network, this PC knows that the DNS server is not local. And it also knows that it should use its default gateway. Now, if the ARP cache on this PC doesn't have the layer 2 mapping for the layer 3 address of the default gateway, which in this case is .1, R1's address on the .10 subinterface, what happens? We very well might see an ARP request that says, hey, I'm looking for 172.16.10. Whatever the default gateway's address is, I'm looking for your layer 2 address. Could you please respond to that? And after that, we'd probably have an ARP reply. So there'd be a couple packets, ARP request, ARP reply. Fantastic. Once we've learned the layer 2 address, we then very likely would have DNS involved. That would go out to the internet, and the DNS server would respond back with the IP address or addresses of google.com. And then when the PC now has the IP address or addresses of google.com, it would pick one of those and send out a TCP three-way handshake, or the first of the three-way handshake, out to google.com to set up a TCP session and then get the content from google.com. Fantastic. I think that's what should happen as well. Now, if any of those components fails, of course, we're going to have a user that's not so happy because it's not going to go ahead and be successful. Now, it just so happens that I've got this exact topology in GNS3 waiting for us. And my question for you is this. If we told Wireshark to go ahead and start listening at point A, and also to start listening at point B, and at point C, and at point D, as in David, if we told Wireshark to start doing captures at each of those points, which, by the way, is a huge benefit of using GNS3, is because it has built-in Wireshark integration. It's really, really cool and really easy to do. My question is, would the traffic be the same at each of those points? Now, think here first. If this client does an ARP request, that ARP request will be seen on this network segment, but it won't be seen at C or D because the ARP stays in the broadcast domain. Also, as that traffic goes on the access link versus on the trunk link, if we capture it here, we're going to see the 802.1q header on that frame as opposed to not seeing it here on the access port. So those will be some differences. Another difference that we're going to see, for example, if this guy's going out to google.com or he does a DNS request out to the internet, is that the layer 2 addresses are going to change at every single router. Because remember, our basics, our fundamentals will go like this. The PC, if a packet is going out to the internet, the PC is going to forward that layer 2 frame to the address of the router. The router is going to see that layer 2 address, de-encapsulate it, see the IP address he's trying to go to. He's going to re-encapsulate it with the next hop layer 2 address as he forwards it. So that layer 2 address is going to change from here to here to here, and the IP address at the layer 3 will be the same until what? Until the source address happens to be changed if there's any NAT in place. And it just so happens for this demonstration that I have R2 also configured as a NAT device. So as the packet from, for example, 172.16.10. Whatever this device IP address is, let's say .2, when he goes through this NAT device, he is going to have his source IP address changed. So after we go through NAT, the source IP address will be changed at the layer 3, and the packet will be forwarded on its way. Those are some observations that I have regarding the traffic that we're likely to see on this network. Now, the beautiful thing is we can actually tell Wireshark to start sniffing at these 4 locations. We can start the captures running, and then we can actually launch the traffic and look at the individual trace files that Wireshark is collecting for us. So this is my GNS3 topology to support that. What I've done is I've set up this to represent a VirtualBox host-only interface, and that's representing VLAN 10. This second virtual host-only interface is representing VLAN 20. These are access ports coming to a 3700 series router with a switch module in it, and this is a trunk port coming right here. In the Nugget download area, I have for you the configuration for this 3700 acting as the switch, as well as the configurations for R1 and R2 if you want to go ahead and use those configurations. What I want to share with you here is that inside of GNS3, if you do the all-in-one installer for Windows, it's automatically going to install Wireshark for you. If we go to Edit and Preferences in GNS3 and we go down to Capture, it's going to specify exactly where Wireshark is, and it also gives you an opportunity to tell Wireshark where you want it to save its files. So in my case, I have a special folder called GNS3 root Wireshark series captures, and that's where I'm going to put the capture files. I'll also have those up on the Nugget Lab download area, so you can download those and have access to the exact capture files that we're doing in this video. So by default, the install for Wireshark automatically integrates with GNS3. There's nothing you need to do except perhaps change the default folder for captures. And if for some reason you went later and installed a newer version of Wireshark in a different folder, you just have to come back here and simply specify where that new executable is so it can go ahead and run right out of GNS3. So I just wanted to go ahead and show you where that was. Now for doing capturing, it's really simple. In fact, what I'd like to do just for convenience, not required, is bring up a capture pane right here in GNS3. And to do that, we're going to go under View and under Docs, and I'm going to go ahead and select Captures. And that brings up the capture dock or pane right over here. And if we want to do our captures, look how easy it is. We simply right click on where we want to capture. This is the access link out to VLAN 10. Just right click and say I want to start capturing. In this example, this switch port is Fast Ethernet 1/2 off this switch module. So I'm going to go ahead and click OK for that. And it shows that it's currently running up here. I'm going to go to this link between the router and the switch module, which is a trunk. I'm going to right click that and say start capturing. I'm going to go ahead and tell it, now I have 2 choices here. I could label it as R1's gig 10, or I could label it as switch module FA11. It really doesn't matter. It's the same traffic on that link. I'll click OK there. Next, if we want to capture the traffic between R1 and R2, we could right click on that, say start capturing, and I'll call this R1 gig 20. Again, I have 2 choices because it's between 2 routers. I'll select OK, and then this right here, this link, gig 2/0, this is after port address translation. NAT happens to it. So we'll right click this and say start capturing. And now I have 4 captures running. Now check this out. If I right click and say stop all captures, that turns them off. And all that data that it collected automatically got created as 4 separate files sitting in my captures folder where I told GNS3 to put it. If we open that up And let me bring that over. Now what I'd like to do is delete these 4 files and have a nice clean start, because once we've specified in the capture pane over here, we could right click and say start all captures, and it will simultaneously start capturing at each of those 4 locations into their respective files. It's way, way cool. So here's what we're going to do. We're going to take a Windows 8 machine sitting right here. We have captures happening at points 1, 2, 3, and 4. And let's go ahead and I'm going to flush the DNS information from the cache on this PC, because I want to make sure we see the DNS. If the PC has cached the DNS information, it might not do a DNS request. I'm also going to remove the ARP entry, if it's there, of this PC for its default gateway. And that way that will show up as well. If, for example, he had already ARPed and learned the layer 2 address of his default gateway, he's obviously not going to go ahead and ARP for it again if it's already in his ARP cache. So I'm going to do those 2 things just to make sure we can see all the traffic between the PC and the router, including the ARP and the DNS. So having said that, let's go to this Windows 8 machine and fire off a request for google.com. All right, so here's our Windows 8 machine. Let's do an ARP-A. And there indeed in the ARP cache is the default gateway. That's R1's address right there, and that's his layer 2 address. So let's go ahead and I'm going to clear that. I wrote a little batch file called flad. It's flad.bat, and what it is going to flush the DNS. It's also going to remove that entry, and there's the commands right there for it as well. So there's the commands. I just didn't want to have to type it out. So ARP-D is going to remove the ARP entry for this IP address, which is its default gateway, and ipconfig/flush DNS. Somebody's going to flush the DNS. So now with that flush, let's go start our captures back in GNS3. I'm still going to right click over here and say start all captures. We'll go back to our Windows 8 machine, open up a browser, which by default has a home page of google.com, and then we'll go back to GNS3, and we'll say I want to go ahead and stop the captures, just like that. So in my GNS3 settings, I had told it I want to save any captures you create in my Wireshark series captures folder, and there are the 4 files, the 4 trace files that it just created for us. What I'd like to do is rename these files so that when you see them, when you download them from the Nugget Lab area, you know exactly where they took place. So the first one was the switch module to our VirtualBox network. I'm going to call this number 1 client network, because that's exactly what it is. Next, I've got the switch module going to R1, which is our trunk. So I'm going to call that 2 trunk to R1. Because that's the second order for going from left to right. Next is R1 to R2, which is perfectly named. Just going to put a 3 in front of it so it sorts a little better. And finally, we have the last leg of the journey where PAT was happening, and that is, and let's call that trace number 4 after NAT. And let's sort those by name, and there's our 4 files in order. So we'll start with this one. And again, this represents this leg of our journey. Now, if we wanted to collect this on a live network, we could get a tap and physically put it in line between the switch and this PC, or we could have configured port mirroring on another available port on the switch and told it to copy all the data as he's going out of or into that client port over to the second one where we could have Wireshark listening. And one of the beautiful things is that we can jump into so many places very easily in GNS3 that it makes it very, very convenient for us. So let's open up this capture file. So it looks like we caught the ARP, which is great. So if I bring up this a little bit and give us more real estate here in the details pane. Also, if we want to get rid of the bytes pane, we just go to view and specify we don't want to see packet bytes, and that gives us a little more real estate down here. Also down here at the bottom, we have our status bar. So if we rearrange this a little bit so we can see it all, it's showing us the file that we're currently working with. It's also showing us the number of packets that all 80 of the packets are displayed. None are currently marked. And let's take a look. So here we have an ARP request. Fantastic. So the source MAC address is the source MAC address of our Windows 8 box. I put a whole bunch of 8s there so it would stand right out. And it was broadcast because it didn't know the layer 2 address of the person who owned the IP address that he was looking for. And he was looking for, it says, 172.16.10.1. Now, fortunately, the router heard that and replied with packet number 2 and says, here's your reply back. And the answer is MAC address C47D4F111111. That's my layer 2 address. And here's my layer 3 address of the responder who's sending this reply. Next, we have a DNS request. Fantastic. We're asking for, hey, I need the IP address of google.com. And that went out to 8.8.8.8. And the reply came back to us at 172.16.10.2. And the answer was, let's go ahead and right click and say, I want to expand this entire subtree. And scroll down. We got a whole boatload of IP addresses regarding Google. So we have this one and this one and this one. It appears, based on the rest of the conversation, that we used that one right there. But we had multiple to choose from. And all those responses came back in a single DNS reply. Then it looks like we have a three-way handshake right here. So there's our SYN, SYNAC, and ACK. And then we have our GET, and it's off to the races. Doesn't look like we have any errors whatsoever. It looks very, very clean. So let's go ahead and close that, and let's take a look at the next leg of our journey, and that's right here. Now, any traffic between the router and this switch, because it's a trunk, should be virtually identical to what we saw over here, except it's going to have the additional overhead of the 802.1q wedged in between the layer 2 header and IP. So let's take a look at it. So sure enough, it looks very, very similar. We have ARP, we have the ARP request, the ARP reply, the DNS request, the DNS reply, and then the TCP working its way to an HTTP session. Fantastic. If you'll notice down here, though, check this out. Let's go back to this ARP request for a moment. So the Ethernet header says, you know what? This is an Ethernet header. Here's the source address. Here's the destination address at layer 2. And here's the next protocol to go to. See, IP is hexadecimal 800. 802.1q is 8100. So that's how anybody who's de-encapsulating this frame knows, oh, here's what's coming. It's going to be 802.1q. And sure enough, it's right here. And the most important aspect for this discussion in the 802.1q header is the VLAN that this frame is associated with. And it's right there. The 802.1q header also includes the information on the next protocol. In this case, it's ARP, which is 806. And here's our ARP request right here. If we go down to the DNS, for example, we're still going to have that 802.1q header information, very similar to all the other packets that are coming from that client through the network. One thing I did do is I turned off spanning tree on the switch. I didn't want to have those little hello messages every 2 seconds mixed in with the rest of our packets. Although you and I both know we could set up display filters so we wouldn't have to look at them. So let's close this, and next let's take a look at the traffic between R1 and R2 right here. And what do we expect to see here? Well, here it's not a trunk, so there will no longer be 802.1q headers, and the source MAC address for traffic going this way will be gig 2/0 of R1, and the destination layer 2 address will be gig 10 of R2 for traffic going from left to right. So let's open up this third capture file as well. We can open that up by just double clicking on it. Now you'll notice here we don't have any ARP messages, at least not the one from the PC. And that's because ARPs stay in their own broadcast domain. They don't leak out beyond their own broadcast domain. So it never made it to this segment between R1 and R2. We do have an OSPF message, which is cool. Then we have the DNS request, the DNS reply, and the TCP traffic based on the HTTP session. Now, at layer 3 and higher, all this information is going to be pretty much the same at points A, B, and C. However, once we go past the router doing network address translation, the layer 3 address is going to be swapped out. The source layer 3 address from the client, which currently is this guy right here, on the NAT device, whenever it sees these source addresses of 172.16.10.2, it's going to swap that out with whatever it's been configured to use for port address translation or NAT, as it forwards the packet out to the internet. So when we look at position D for the trace, this source address is going to change to whatever that NAT device is assigning. Let's go ahead and open up trace number 4, which is right here after NAT. If you'll notice in our fourth capture, we have a lot more going on, and that's because I have a whole bunch of other network devices in that space on the right, if you will, of R2. So if we take a look at these, look at it, we have a broadcast. So somebody's looking for a 192.168.144. This ARP packet is not related to our discussion at the moment. So if we wanted to, we could actually remove some of these. How do we do that? Well, the quickest way is to, you know what, this SSDP, I really don't want to go ahead and include it. So we can say it's user datagram protocol. We could open up that detail and simply say destination port 1900. I want to apply as a filter. I want to not select that and simply hide it. We've got spanning tree going on on this external network. If we want to get rid of that, simply highlight it. I'm going to select that detail, spanning tree protocol, right click on it, and say I want to apply as a filter and not selected, just like that. So that's going to remove my destination port UDP 1900, plus it's also going to remove all STP traffic. So as we take a look at this DNS, which is really our first packet of interest regarding that client going out to the internet for the DNS request, if we look at the layer 2 information, the source MAC address is going to be R2's right-hand interface, the gig 2/0 interface, and the destination layer 2 address is going to be its default gateway, or the next hop of whatever it's using to go out to the internet. I asked myself the question, Keith, what would I love to have if I was starting to practice and work with Wireshark, especially after a video just like this one? I would want this graphic right here, and I would also want those 4 capture files that are capturing 1, 2, 3, 4 different points in our network. So here's what I did. I have placed all of that information in the Nugget Lab download area. There's a picture of this topology that you can have open up on your screen, and I have the 4 capture files, the ones we just looked at in this video. I've also got the configuration files for this switch module router and also R1 and R2 if you're interested in those. I wanted to make sure that they were available. That's all in the Nugget Lab download area. Your homework assignment is really simple. What I want you to do is take some traffic that you saw in trace 1. It could be a DNS request. It could be one of the TCP or HTTP packets that went all the way to the internet. Once you identify a single packet, other than ARP, because ARP stays local, but once you identify a single packet and out of trace 1, I want you to go into trace 2 and find that same packet, and then go to trace 3 and trace 4. What this is going to do for you, it's going to give you some exposure to what a packet looks like at different points in the network. It will also give you some excellent practice in navigating and working with the interface on Wireshark. Now, the good news is, in these traces, there's less than 100 packets in 1, 2, 3, those traces. And number 4, because it's a crazy network out here and I have a lot of other gear running. Now, in trace number 4, because there is a lot more going on, there's going to be some additional packets there, and that will also give you the opportunity to practice with a display filter. Looking at the details of a packet, right-click on some aspect that you don't want to see in your output, right-click and simply add that as part of something you do not want to see as part of a display filter. If you want to practice by adding new columns to your display, this would be a great opportunity as well. Simply go to the IP header for the packet that you're interested in. Go to the time to live field, right click on that and say add that as a new column. What you'll notice is the packet, anyone you pick, the DNS or TCP, you'll have a TTL of X, for example, right here. And as it crosses each router, it'll be X minus 1 and then X minus 2, etc. as you look at it at various points in the network regarding the TTL, the time to live. I have had a great time in this video with you. I appreciate you joining me. I hope this has been informative for you, and I'd like to thank you for viewing.